Hello, welcome back to this second video on natural language processing zero to hero. So in the last video, we performed the text pre-processing on our data frame, and we saw all the steps involved in text pre-processing and in what scenarios, in what business cases we should be using lemmatization or stemming, and in what scenarios we should be using stop words or we should not be removing stop words. So this is what we did in the last video. In this particular video, what we are going to do is we are going to look at different vectorization methods like bag of words, Tf-IDF, Word2Vec, and what we'll do is first we will vectorize all these text into vector format and then use SVM classification method, a machine learning model with these vectorized data to perform sentiment analysis. So what I have done here is, I'm using sklearn feature extraction method, from which you can use counter vectorizer for creating bag of words, and you can use Tf-IDF vectorizer for creating the Tf-IDF matrix. Now, I hope you guys have a basic idea about like what bag of words is or what Tf-IDF vectorizer are. So there are major problem with bag of words or Tf-IDF vectorizer. There are two major problems. The first problem is basically it creates sparse matrix. So you have a huge dimensionality, which makes computational cost very expensive. And the other problem is it does not capture any semantic meaning inside the text. So these two problems are basically solved by the Word2Vec model, and we'll be using Gensim model to build a Word2Vec model here. And so yeah, I'll just go ahead. This is the function that I have created, and here we are taking the training data and test data, and then we are creating a SVM model here. We are fitting it, and then we are predicting it, and then we'll be calculating the accuracy. So this is the function that I have created for bag of words and Tf-IDF, and this is the function that I have created for Word2Vec. So what we are doing here is we are building our custom Word2Vec model, and these are the hyperparameters, like the vector size, number of dimensions you want in your final output. So I have just taken it as 100. This is a hyperparameter. You can play with it, and you might be able to get better results or worse results. So it's like an experimentation thing. You'll have to try it on your own. Window is basically what is the window size. So in Word2Vec, there are two types of Word2Vec model. One is called CBOW, and the other one is skipgrams. So basically you choose the window size, which is very similar to n-grams. So here it will be 5 grams. So your word will be in the between, and 2 words on the right and 2 words on the left will be taken for understanding the semantic meaning of that particular word. So you can play with this window size as well. You can increase the window size, and that it would be able to capture more semantic meaning because of that. Then these are the hyperparameters you can play with and try to improve your model. And once my Word2Vec model is created and trained, then I vectorize the data using this created Word2Vec model, and then I use SVM model for the prediction. So this is just xtrain and ytrain, xtest and ytest I have created. I'm using the preprocessed text column that we created in the last video after pre-processing the textual data that we had, and then I just run this function. So basically what I got when I ran for bag of words, I got a very good accuracy of 88%, which is really nice. The only thing is we had a lot of data in our train data. We had around 40,000 rows of data, so it was a huge textual data that we had. And as I mentioned, bag of words and Tf-IDF create sparse matrix, so there were a lot of dimensions. Because of that, it takes a lot of computational resources as well. So it took almost 50 minutes to run this model and finally give me an prediction, and the accuracy was really good. Then I used the Tf-IDF model, and Tf-IDF took even more. Tf-IDF, how it is different from bag of words is that bag of words basically give equal importance to all the words, all the text which are there. But Tf-IDF basically tries to give importance to those words which are rarely used in the document by using the log function. So it takes more time for the calculation, and that's why it took around 1 hour and 7 minutes for doing everything. And the accuracy that we got was really amazing. I was surprised to see this accuracy. Our accuracy was 90%, which is really nice. And then I tried using the custom built Word2Vec model. So this was trained, and then this gave a prediction very quickly in just 3 minutes. But as you can see, our accuracy was really bad. It was just 50%. So as I said, you have to play with these hyperparameters, and Word2Vec is a neural network based model. So you have to train it a lot. You have to spend a lot of time in training it, it uses a lot of computational power, and you have to provide a lot of data as well for training this model. So for that reason, I think our model did not perform really well. So you can try to make this better by feeding in more data for training the model, by playing with the hyperparameters. But other thing what you can do is basically use pre-trained Word2Vec models. So as I mentioned, training a neural network model is very expensive. Rather, why not use open source available models? So one of the best models available for Word2Vec is by Google, called Word2Vec Google News. This is around 1.6 GB in size. So if you want to use it, you have to download this model. And it has been trained on over 100 billion parameters, and it has 300 dimensions. So the dimension size that we selected here for a custom model, vector size, this is 300 in case of the Google Word2Vec model that we have. Then I used this, and I combined it with the SVM, and I was hoping to get a better result, and indeed I got much better result. This is approximately equal to 86%, and it is not. So this was fast. The only time what was consumed was basically in downloading this. So you can download it and keep it in your local folder or in your production environment, and then just use this model for the prediction. So 86% is not bad, but it is, bag of words or Tf-IDF model performed much better than what we got from using Word2Vec and SVM. So you can try it with other models as well. You can vectorize it using Word2Vec and try using some other machine learning models. Maybe you can get a better result. You can try boosting models. Boosting models perform better with tabular data, but yeah, you can give it a shot. It's all about experimentation. So this would be all for this particular video. In the next video, I'll be building recurrent neural networks. I'll be starting with vanilla RNN, which is a simple recurrent neural network, which has its own problems, because of which we'll go to the next model, which would be LSTM and GRU, and then we'll be using bidirectional LSTM as well. Then by end of the video, in the last video, we'll be using transformer based model like Distilbert and Roberta model. So that will be all for this video. I'll see you in the next video. Till then, happy learning.